Hello everyone, welcome to POC TV. As part of a proof of concept today, we're going to see about Python Pandas chart visualization. Objective of this proof of concept is to understand chart visualization in Python Pandas. Steps involved in this process: load required libraries, some terminologies, basic plotting, more visualization libraries, and summary. Loading required libraries. We are loading three required libraries for this proof of concept: matplotlib.pyplot. We are importing this library as plt, and we are importing pandas library as pa, and we are importing numpy library as np. We are using plot close all at the end for closing all the plot windows. Some terminologies and explanations. np.random, this is basically seeded with 1, 2, 3, 4, 5, 6 numbers like that. This is basically a random number. Come sum, cumulative sums. Close off is used to close a figure window. Plot is used for drawing the graph or chart. Random function creates an array of specified shape and fills it with random values as per standard normal distribution. First time importing all these libraries by executing this command. So now all the libraries are imported. In order to know more about this Google Colab, use the link in the below description to learn more about Google Colab setup. Basic plotting using series. So how to plot graph with a series? I'm using a variable as SAR for series, and then pa.series of np for numpy random function, and then I'm index. Again, I'm using a PA. So I'm using a pandas as the PA library. Date range, I'm giving today's date. And length period, I'm giving 100. I'm saying, the variable, series variable equal to series dot come sum of. I'm using a cumulative sum from this output. Then I'm using the variable dot plot of. So all the cumulative values from this value, I'm plotting as a graph. So I'm closing this window, so I don't have any results now. After I loaded all the libraries here, this has to be loaded once before you can execute this successfully. So if I run this, so you can see the graph is plotted. I gave a date range as June 1st, 2022. You can see starting with June 2022, and it's plotting the graph with some random values. June, July, August, September. Has taken 4 months to plot the values. If you want to change or increase the random values and also increase the period, you can do that. I'm increasing the random values to 1000, increasing the period also to 1000. So if I run this again, you can see a difference here. So it started with July, and then it says then 2023 and 2024, 2025. So it is taking July, January, July, January, July, January. So that's how the plotting goes. If I increase this to 10,000, which is maximum, you can see It is starting with 2025, 30, 35, 40, and 45. Every 5 years, it is plotting a graph. So I'm setting this back to 100, where we started. So that's the basic plotting using series function. Now I'm doing a basic plotting using a data frame. I'm using a variable as datf. I'm saying pandas pa.dataframe of random function. I'm passing the same value as I used before, 100, 4 for a 4 different list. I'm indexing the series index, which I have taken from here, and then columns equal to I'm listing B for blue and O for orange and G for green and R for red. I'm using the same variable DataFrame dot cumulative sum of. I'm plotting the figure of function, and then I'm using the same variable datf that plotting the final graph. So I'm exiting from here, running this, so you can see the 4 column list: B for blue, O for orange, G for green, and R for red. It's been plotted here. It's taken as June 2022 and July, August, September. So the value, the original index we have created here, that same value is being passed into the second data frame graph. If I increase this to 1000 for random and then periods, I would be able to increase the same here. And then running this, you see it's a little different now. So same way, if I increase this to 10,000 for the random number and the periods, I'm increasing the same here with 10,000. So you can see it's so dense. The graph is pretty dense. 2025, 30, 35, 40, 45. So that's how it is plotted. And how to plot, one column versus another using X and Y. So I am using a new variable, datf1. So pandas dot data frame, passing a random function. So basically all the values I have given above should match this one. So I'm increasing this to 10,000 as well, passing 2 columns, O and G, orange and green, dot cumulative sum of. And then I'm saying same variable equal to pandas PD, series of list range length, and I'm passing the datf, which I have before, this particular value here. Then I'm using the datf1 variable to plot the graph for the other two, which is blue and orange, which is mapped against X and Y axis. So I'm exiting the graph here and running this. So you can see the pretty dense graph here. It's because of the same value we have applied from the top to bottom. So if I change this back to 100 for a random number as well as periods, so this looks pretty neat. The same way I'm reducing it here, 100. You can see a lean graph. So now if I reduce this to 100, basically the first plotted graph value from the series is passed to the second data frame. Second data frame, values is being passed to the third graph. So now you can see it's pretty neat. So that's how you can plot one column versus another. Using XY, you can map a different column values. So more visualization libraries. In the visualization, you have several other libraries available. Altair is a declarative statistical visualization library for Python. Boca is a Python interactive visualization library for large data sets that natively uses the largest web technologies. When you are using big data related technologies, or if you do a data mining, the extremely large databases, rocket science, industry related data sets, medical data sets, they are like extremely huge databases. So for those kind of big data related ones, you can use this library. Then Seaborn, it's a Python visualization library based on matplot library. IPython Vega, this leverages to create plots within Jupyter Notebook. So similarly, there are many other visualization libraries you can learn and then play around beyond this. To summarize what we have seen today, loaded required libraries. We have seen some terminologies, explanations, and basic plotting using series, basic plotting using DataFrame, and plot one column versus another, and more visualization libraries. I hope you enjoyed today's session. Thank you.